Hello everyone and welcome to Fire and Sound Solutions by Building Type. This webinar is sponsored by National Gypsum Company. My name is Tao Nguyen, AWCI's Education Program Manager. And before we start, a few housekeeping items. Attendees should be on mute throughout the whole presentation. Should you have a question at any time during today's broadcast, please submit it using the question box in your GoToWebinar dashboard. We'll have a short Q&A session at the end of the presentation. At this time, I'd like to introduce our presenters, Scott Hughes and Chris Whitmire. Scott Hughes is a construction design manager for National Gypsum Company, focusing on the Northeast and Mid-Atlantic regions. With 26 years in the building product industry, he provides solutions for architects and specifiers by reviewing specifications, selecting appropriate products for specific applications, and presenting educational courses. Along with Scott is Chris Whitmire. He currently serves as Director of Product Marketing, leading product and system marketing management, while overseeing the technical marketing and 1-800 National Construction Services teams. He is a 13-year veteran at National Gypsum Company. So welcome, presenters, and Chris, I'll hand it over to you.
Great. Thank you for the introduction, and good afternoon, everyone. Just want to start by thanking everyone for taking time out of their busy schedule to join us for today's webinar, Best Practices, Fire and Sound Solutions by Building Type. Before we get into the presentation, I wanted to just take a moment and touch on who we are here at National Gypsum. We're headquartered in Charlotte, North Carolina, and we are the largest American-owned drywall manufacturer in North America. That's something we take a lot of pride of here at National. We have manufacturing facilities located throughout the entire United States with the ability to service all areas of the country. 2025 is it's an especially important year for us here at National Gypsum as we're celebrating our 100th year anniversary. Again, something we're very proud of. Look forward to seeing many of you here in Charlotte at Build 25, AWCI's convention and expo, as we celebrate this significant 100-year milestone. From a brand standpoint, we go to market under 4 brands. Gold Bond, which is our gypsum board products, Permabase, which is our cement board line. We also manufacture roof cover boards under the Dexel brand, and our Proform brand covers the finishing products, ready mix, textures, setting compound, bag goods, etc. In regards to today's discussion, one of the solutions we offer here at National Gypsum to address the concerns around sound in the built environment is our sound dampening gypsum board. That's SoundBreak XP. We have a 5/8 and 3/4 inch thick product, and that's both for wall and ceiling applications. And we offer this in both a Type X and Type C. For those renovation projects, we also have a 5/16 SoundBreak XP retrofit product. This product goes over existing walls, no demolition required. So we have many options available to you to address your specific sound situation. With that, I'll go ahead and turn things over to Scott Hughes. Scott, the floor is yours.
Thank you, Chris. Appreciate it. So today's outline, we're going to start with just a brief introduction, fire and sound designs and what they're all about. Then we're going to spend a few minutes. It's important that we kind of do, I like to call it an education or a college 100 level course on acoustical terminology. Most of what I do every day is talk with architects and consultants about acoustics and about fire designs, and there is, of course, a lingo. So I want to make sure everybody's kind of comfortable with what these terms are and all the different things that can affect both sound as well as fire in our buildings. So we'll do that. We're going to go through some sound control strategies, meaning, what are things that we need to do in order to get higher performing walls when it comes to both fire as well as acoustics. And it's important to note too, if we focus too much on a high STC, which I promise you we're going to define all of that, a high STC rating, but it's also a fire rated wall, we need to take that into consideration as well, because there are specific UL requirements when it comes to fire ratings. And then we're going to walk through the solution. So examples will be double studs, staggered studs, resilient channel, and of course, sound break, which is a gypsum board. It's what we'll call a damped panel. And I'll define that for you a little bit better as we go through. Throughout the presentation, I know I have a separate bullet point here for codes and third-party recommendations. I'm going to kind of tease that out throughout the presentation. It's not really a section, but there are some specific codes, language, as well as a lot of actual third-party recommendations for specifically acoustics, STC ratings. So I'll make sure that we mention those as I go through. So when an architect is putting together the plans and the specifications on a building, there's of course several things that they're very concerned about, but the two of the top three to top four are definitely going to be sound and life safety. Now, life safety is probably number one, right? We need to build safe buildings for people that if there is a fire, there's ways for them to get out. So of course, we'll talk a little bit about that, but the focus is really going to be to the left side. And that's what are the requirements for STC ratings and IIC ratings. So we'll talk a little bit about what that is and define that for you in just a little bit. But the quieter the environment it is in a building, the easier it is for, if it's a school, kids to concentrate. If it's an office building, adults to get their work done, right? I mean, think about what you do for a living. A lot of you are in the office sometimes. A lot of you are on the job site sometimes, but you have to have your quiet times to get things done, right? So architects are designing on purpose, right, partitions and floor ceiling assemblies that have higher qualities to them as far as reducing sound through them. So that's really our focus. It's going to be acoustics, and we are going to talk a little bit about fire as well. So let's get into it. Let's talk a little bit about, let's get into our little 100 level class. Got a couple slides on each one of these bullet points. Some of it's very basic, but it's super important. Again, we need to know the language, particularly when we're talking to owners reps, when we're talking to the architect who's on the job site, the QA, QC folks, they all will know the language. So we all want to make sure we're all thinking the same way. So structure-borne sound we'll start with. Airborne sound is what STCs are all about. So I will spend a little bit more time on that one. Flanking sound is something that you really got to consider, and you'll see it when I have the slides up here and some pictures of what that's all about. Something that we really need to take into consideration when we're actually putting our partitions together. Decibels, we're all familiar with those, but volume obviously has an awful lot to do with how much sound gets through a partition. And then we'll better define STC for you, sound transmission class. Unfortunately, sound is just not black and white. It is. We all hear different, right? I mean, some of us, the older we get, the less we hear. If you were in a rock band all your high school life, you know, with loud music, or you listen to loud music all the time in the car, as you get older, that actually does affect your hearing. So sound is a difficult thing to talk about because, again, we all hear differently. But we'll get there. We'll have a couple slides here to kind of get us all on the same page. So first is structure-borne sound. I have 4 daughters. They're all in their 20s now, but when they were younger, they had the Xbox game. I think it was called Dance Mix USA, right? So they would play this game. They would laugh, jump around, dance, have fun, loud, jumping up, you know, again, jumping up and down. And if I had someone living under me at the time, I probably couldn't let them play because all of that vibrational energy goes through the density of our building products and allows sound to go right through it. So the harder or stiffer a material, the easier it is for sound to go through it. So we need to take that in consideration. On a floor ceiling assembly like this, you know, we need to actually separate our floor here. So if we have a hardwood floor like's being pictured, we need some kind of a slip mat or something underneath that because that will absorb some of that energy. But we'll get, again, we're going to, a lot of slides as background, and then we'll tie it all together, I promise, for you. Then we have airborne sound. So that's the focus for today. When I talk about STCs with architectural firms, with contractors and consultants and building rep or owner reps, it's all about airborne sound. So right now, I am producing this airborne sound, right? I'm pushing sound out of my diaphragm, which is vibrating, comes out my mouth, comes to my computer microphone, goes through the internet, out your speakers to you, and the noise that's coming at you hits your eardrum, and your eardrum vibrates. So there's an awful lot of vibration going on, right? The best way to reduce sound is to reduce vibrational energy. So that's what the whole point of our partition there in the little diagram is. Lots of noise to the left, big red arrow, and we're using that partition to reduce the vibrational energy going through that partition to the other side. STCs measure that, big red arrow to little red arrow. What they don't take into consideration necessarily is impact sound. So think of somebody with a high-heeled shoe or a dress shoe that's got a hard sole to it, click, click, click on a tile floor. So those kinds of things are why we have to have other slides and other terms to kind of figure out what's going on there. So just remember, airborne sound is what STCs measure, and it's the reduction of that sound is what we're going for. Flanking sound. So this again is kind of coming back to my dress shoe or a high-heeled shoe. Click, 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 click. Footfalls as you walk on a hardwood floor or a tile floor. That vibrational energy can vibrate right underneath our partition, right to the other side. So there's things like sealants and caulks that we want to do. Now I will tell you, National Gypsum does not, Gold Bond Building Products does not sell sealant. We don't have caulk. We don't sell it. It's not why it's in the presentation. It's in the presentation because it's important to do the little details to actually get the field performance of the STC ratings that we're going for. So caulk will help with that vibrational energy on the floor. Putty pads for our outlets, whether it's electrical, switch, plugs, if it's an IT, whatever it is, hospitals, we're going to talk a little bit about hospitals here. They've got all kinds of penetrations, right? So we need to be sealing those off as well. Anywhere that air can get through, sound can get through. So there's we need to caulk. Now what you see here on this particular partition is caulk on both sides. So we often get the question, do I really need to do that? And the answer is yes, you do, because sound STC ratings work both ways. So I can have on the right side of this partition a daycare, and on the left side I could have a doctor's office. Now we would probably never really do that in reality, but it's a good example. So all that noise on the right versus trying to keep it quiet on the left, or vice versa, doesn't matter. The purple you see there is our SoundBreak XP product that Chris was talking about. It does not matter which side of the wall it's on as far as acoustical performance. Now there's other features to it that we're going to talk about that may make you decide which side to put it on, but as far as acoustics and fire, it does not matter which side. Remember that the SoundBreak that you're going to see, the SoundBreak XP in all my diagrams, is the 5/8 Type X. So it is a Type X product approved in most UL designs for fire-rated wall assemblies in 1, 2, 3, even 4-hour fire rating. So there's no issues in using it in most UL designs. So again, caulk both sides, super important. It just helps to eliminate's the wrong word, reduce sound vibration from footfall. Now, that was the floor. Let's talk about the walls and the ceiling. So if we picture a room, if you're in a room now, you look at the 4 walls that are around you, right? When you open and close doors, the wall vibrates, sure, right? If you open and close your window, the wall's going to vibrate a little bit, particularly if it's a stiff window to open and close, right? And that noise vibrates right through the wall, past the partition into the next room. So we actually need to do this caulking around the entire perimeter of the wall. So let's assume one of the walls in the room you're in now is the wall that we need a very high STC, a good performing wall that not a lot of sound can get through. Let's call it a 55. What we'll do is leave a 1/4-inch gap around the entire perimeter of the wall, not every single board, just the perimeter of the entire wall. We'll fill that with an acoustical sealant or a flexible sealant, caulk, and then the taper can come in and use the joint compound and tape to finish off the joints. If we leave that 1/4-inch gap, and I don't have to tell you all, 1/4 inch is not very big, right? So it's just, if we leave that little gap all the way around the perimeter, and the folks that are coming in to do the joint compound and tape decide to, oops, hey, look at this gap, let's fill this in real quick before anybody sees it, we've totally defeated the purpose of using SoundBreak or using a double stud or staggered stud wall that we're going to show you here in a minute. Totally defeated the purpose of it, because that little bit of gap will actually allow sound to go right through it. So let's assume the 1/4-inch gap is not filled, the tape and joint compound go up, we've just lost 10 points of STC. That is a significant number, and I promise you we're going to talk a little bit more about that in just a second, on what 10 points of STC really means. So keep that in mind. Here's a good example of stuff and flutes. There's lots of options here. We're just showing you the simplest. Get a little mineral wool, stuff the flutes anywhere that air can get through that system. Obviously, sound can get right through it as well. Water get through, and then of course, sound is getting through as well. Now, in this application, we may or may not have a drop ceiling, and the drop ceilings are designed to help with that. We still need to stuff these flutes and stuff any holes, because sound's going to get through. It just is. It just is. So we need to make sure we're plugging all the gaps. Now, electrical code outweighs anything I say, focused here on acoustics, but the green check mark is showing that there is an outlet box, 1 per stud cavity. Instead of having, like the X, the red X, 2 outlet boxes in the same stud cavity. Now, I know there are several conditions where we have to have multiple boxes in the stud cavity, but if we don't, and we can separate them out, that means I can get more glass bat insulation in there, and that will help achieve the higher STC ratings. If I've got an outlet box, there's no insulation between the box and the drywall, right? You only have the option to use these putty pads that you see there in the picture. They do work, though. I mean, they do work, but not as well as the insulation would throughout the whole thing. So let's talk about fire just for a second. So UL fire rated wall partitions, if they are tested, a UL design, say U465 comes out and on your plans, and that's what you need to install on the job site, and you see that the architect is saying, hey, I want insulation in this wall, but the UL design wasn't tested with insulation, that's okay. All right, UL allows you to add insulation to any wall partition you want to. It does not take away from the fire rating. Now, that does not necessarily apply to floor ceiling assemblies. Okay, you can add insulation to those, but there are other things you have to do. And one of them is you have to add an additional layer of drywall to the ceiling or to the lid. So there's a whole discussion there, but I just want to actually just focus in on higher sound is always going to, or higher STCs will always happen when we add insulation. And when we add insulation to a partition, it will not affect negatively our fire rating. UL allows it. It says it's right on their website. But if you're going to do it in a floor ceiling assembly, then we need to actually look at the fine print. Okay, so we'll leave it at that for right now. Bottom line, add insulation. Nothing to do with R value, all about absorbing sound. So here we've got decibels. So we're all familiar with this, right? At elementary school, I think we learned about decibels. If just 2 of us are in a conference room talking to each other, we're probably talking about 60 decibels. That would be normal conversation. I often do these presentations in front of large groups. I have to elevate my voice because the people in the back need to be able to hear. So I would probably be talking about 65 decibels for them to hear. If you look at the chart, once you get to about 100 decibels or more, if you're exposed to that for too long of a period of time, it will actually cause physical pain in your ears. If you've ever been to an indoor rock concert, say, I'm going to show my age here, but the Who, AC/DC, any of the metal bands that are indoor concerts, Phil Collins, all of these guys, Guns N' Roses, you're at a really, really loud concert. And when you left that concert after 3 hours, your ears were probably ringing, right? So that's not good, by the way. You don't really want your ears ringing. That's going to cause hearing loss over time. In fact, all those bands I just mentioned, most of them are clinically deaf. They have to have implants and everything to hear. So you don't want to be exposed to those kinds of decibels. But when we look at the decibel chart here at the bottom, a change in sound and what it means for our hearing, a 1 to 2 decibel change. So from 60 decibels, and if we go up in decibels to say 62, we really don't notice that as adults, okay? It's really not till 3 to 5 decibels that it is very noticeable. So that 60 to 65 is very noticeable. And when I'm in front of a group, I can start talking a lot softer and you get the good feel for that. But that's kind of the goal. If we can get anywhere from 5 to 10, look what happens at a 10 decibel change. So the higher the decibel, the louder, but that's not what we want, right? We want our partitions to lower it. So let's go from 60 decibels to 50 decibels. We've actually cut the sound in half by doing that. So that's a great goal. If we can get that sound cut in half, we're doing a great job with our partitions and our floor ceiling assemblies. I'll mention the 20 decibel change. It's 4 times louder if we're going up in decibels, or if we're going 20 decibels lower, some 50 to 30, it's 4 times quieter. That's a little bit more difficult to do. So we'll focus really on this 3 to 10 decibel change range. Now, when it comes to STCs, STC rate numbers don't correlate directly to a decibel number. So I can't say, all right, I'm at 50 decibels. I need to get to 40 decibels. So does that mean I need a 10-point change in STCs? Kind of. Okay, is kind of the answer. So it depends on where we are on the scale. It's a logarithmic scale. So an STC is a way for us to compare one partition to another and how it performs at reducing sound through it. So the higher the STC, the better. That means it's reducing more sound through it. That's what we want. We want to reduce sound through it. It's the transmission of sound. So the lower the STC, the more, we'll call it paper thin wall, right? Where you and I can have a conversation right through a wall, say 35 STC, you and I can talk to each other through that wall. You get to a 45 STC, I probably need to yell for you to understand what I'm saying. you'll hear the noise, but you probably need to really listen to hear what I'm saying. Above 50, I'm going to have to yell really loud. So higher the SDC, the better. The lower the decibel, the better. Now, how we test this, the ASTM E90 is the test method. So you see in the upper picture there's 2 boxes. It's actually 2 rooms. One room's going to have a speaker and a microphone because we need to know how much sound's coming out of the speaker. We'll have our test wall, which is represented in the red there. On the other side is another room, 10 by 10 by 10 or 12 by 12 by 12. So it's a box with a microphone in it. And what we do is we start making all this sound. Think of a pink noise or a white noise, that scratchy shh sound, right? So that noise is sent out at 120 decibels, really, really loud. You don't want to be in the room when they turn that machine on. It's that loud. And they're shooting sounds, different frequencies actually, through that wall partition to the other room where that microphone is picking up how much is coming through. So that microphone pulls all this data into a computer software program, and ASTM E413 is the formula for how to come up with a specific STC number for that wall. So the less sound getting through, the higher the STCs. Now, I'm being pretty generic here. There's a lot more to it than that, but for today's purposes, that's a general good assumption. You will hear the term occasionally third octave testing. So if you ever get involved with the architect directly, talking about different things within STC rating, they may want to see actually STC testing. They may require that you furnish that as part of some submittal packages. Maybe, maybe not. But just know that there is what's called third octave testing. That's what this is. That's what we're talking about with STC. Different frequencies and different ranges are tested. So we test from 125 frequency of 125 hertz, which is very low. I don't know that we can hear that as adults. It's really a low humming sound. Think of very large machinery that may make this really low hum, electrical type stuff. And then we test all the way up to 4,000 hertz. Now, 4,000 hertz, as an example, it would be the most annoying high-pitched sound I could make right now through this computer, right? Really annoying high-pitched sound. That would be about 4,000 hertz, and then it get even higher. But for testing for STCs, we only test within that range. So when we look at third octave testing, and we know we're doing a high school, for instance, the high school is going to have older type voices, so maybe a little bit lower type voices. Then the lower frequencies is what we want to look at. So that's why there's all of this testing data. There's third octave testing. There's the STCs. All the different frequencies are tested. Just know that there's a reason and a method behind all of that. Architects are specifying wall partitions, at least they should be, based on these tests and knowing what's in the building, whether it's a kindergarten or if it's a high school or if it's a hospital or whatever it is. So that's why we have all of these terms. Trying not to get too far in the weeds with all that, but just know there's a method to all the madness. So Tao, I think we have a brief survey or a little survey we're going to do where we're going to actually ask you all, what method do you use most to achieve the high STC ratings? And you'll have 4 choices, and just go ahead and fill that out for me. And I can't see the results, but Chris is going to read them to me in just a few seconds. But 1 was add insulation, 2 was wider walls, 3 was gypsum soundboards like the Soundbreak XP, and then 3rd option here is RC1. I couldn't have an option for other, sorry. So just pick one of those, and I'm just curious on what our audience has out there for us. All of them work, which is a great thing.
Come in.
Yep, and I'll tell you, adding insulation is going to help a lot. It can help from 4, 5, 6 points of STC, depending on thickness of insulation. The wider the wall option is probably the best, if you think about it, right? The wider the wall, the harder it is for sound to get through it. But for most of our projects, it's not what the clients want. They want every square inch of floor space. The soundboard makes a lot of sense, and we're going to show you some designs here in just a few minutes in different applications of hospital and school, as well as multifamily, on how all of that works. And I guess from an economic point of view, our resilient channel is probably #1. I'd be shocked if it's not in our results, but if it's just a least expensive way to do things, but there are some concerns with it as well. So
I think we're good here, Scott. So here are the answers to what method do you use most to achieve higher STC ratings. The first option, add insulation, that one came in at 33%.
Oh,
wider walls came in at 11%.
Okay.
Gypsum soundboard, 19%.
All right, we'll work on that one.
And you called it RC1, 37%.
There we go. Add insulation and RC1, two good options. Thank you, Chris. Appreciate you reading that to me. So here's, with all that as a background, here are the strategies, the main strategies to improve our STC ratings. So mass. Now, mass can mean different things. I would tell you that the more different, well, let me rephrase this. Let me use proper English here. The more different types of materials we have in a partition, the better it will perform with STCs. Meaning, 800 layers of drywall, although we would love for you all to install 800 layers of drywall on all your walls, there is a law of diminishing returns. Everything vibrates at certain frequencies, so we need different stuff. So we need mass, we need insulation. Sometimes we use mass-loaded vinyl, so there's a lot of different options out there. Mass helps. Stiffness hurts. So here's where our studs come in. Studs are probably the single most important factor when it comes to STCs. Wood studs stink when it comes to STC ratings. Any heavy gauge stud stinks when it comes to STC ratings, meaning 18 gauge or stiffer just aren't going to perform well because they're so rigid, the sound vibrational energy goes right through it. So that's why stiffness hurts. Best performing stud, 25 gauge metal by far. 24 inches outperforms 16 inches on center. That just makes sense. One less stud per stud cavity, less framing, less chance for sound to vibrate easily through our partition. So your best performing wall, according to the stiffness, is 25 gauge, 24 inches on center. I highly doubt there's too many of us on this call that have ever installed 25 gauge studs, 24 inches on center, unless it was temporary construction. So that's probably not an option. I'm going to show you lots of options to get us where we need to be. Already talked about cavity absorption. Just throw in insulation in there, fill it up. Don't overdo it. Don't overpack it. Just make it fit. You're going to get 5 to 7 to 8 points of STC, depending on thickness and those kinds of things. So no gaps, sound can't get through. Well, I shouldn't say sound can't get through. It reduces sound getting through. And then last but not least, we certainly mentioned it, partition depth. You will see that double studded walls will perform the best, but they're going to take up all the floor space as well. So I'll show you that. We'll get into that here. So let's kind of focus first on healthcare, a little bit on multifamily, then we'll close it out with education. But everything I'm going to say in these three categories will apply to just about any work we do: single family homes, industrial, whatever. Most of everything, there are a few nuances, but most everything I'm going to tell you through in the next 10 minutes here will apply no matter what project you're doing. So healthcare, two things I think of when I talk to architects about healthcare. Number one is actually the HIPAA requirements. So you should not be sitting in an exam room of a doctor's office waiting to see your doctor and know that your doctor's coming to you next because you can hear them saying goodbye to the patient next door, right? We've all heard that, I'm sure. At some point in our lives. So HIPAA says you need to quiet walls so that the conversations are quiet, whether it's a doctor's office or a hospital room, whatever it is. So sound is obviously a big part of healthcare. And then, of course, means of egress, fire-rated walls. Hospitals are Category 3, Category 4 type buildings, meaning that if there's a hurricane blowing through, hospital needs to survive because people need a place to go. Police stations, fire stations, or some schools are the same way. They build them as survivable of hurricanes so that people have somewhere to go. So all of that matters here. Bottom picture is the best picture I could find with what a wall looks like in a hospital room. It's just unbelievable amounts of penetrations. How you keep that quiet is really hard. Machinery's making beeping sounds, right? If you've ever been in the hospital, you know it's impossible to sleep because of all of those things going on. Anyway, so lots of things to think about when it comes to healthcare and trying to keep those walls quiet. Now, I promised to interject some codes and some third-party recommendations, so we'll start doing that here. The Facility Guideline Institute recommends certain STC ratings for specific wall assemblies in healthcare. So architects that design healthcare will follow this FGI guideline. So you'll see the numbers here: the patient room to patient room, it needs to be quiet. Patient room to corridors, pretty low number. But again, if you've ever been to a hospital, patient rooms doors are always open unless the doctor's in there, consulting with the patient. So MRI, very noisy machine, STC needs to be 60. So these recommendations are what the architects are following. So this is why they're asking for what they're asking on the plans because of these recommendations on certain walls. So Common solutions, mass, damp panel, and decouple. We'll start with mass. So again, I mentioned this earlier, as much as we would love to sell hundreds of layers of drywall on every partition, there is a law of diminishing returns. So this particular example would be 2 layers of 5/8X on either side of our partition. We've got 25 gauge metal at 24 inches on center, and we have a very good STC of 56. That is a very, very good performing wall. Problem is, it's 25 gauge metal on 24 inches on center. So I don't think we do a whole lot of that, right? We need to up those studs. Now, you'll notice the UL design is listed underneath there. It's called UL design V438, U411, 2 hour. So this is a 2 hour rated wall. What UL allows us to do in this particular case is beef up that stud. So if we went from a 25 gauge stud to a 20 gauge stud, we can do that as far as UL is concerned. However, that will affect that STC rating. It's going to drop it from that 56 to 53, 52, somewhere in that range. So that's where what Chris is going to show us here in the end and kind of wrap things up is with our sound book. There's going to be lots of opportunities to go through our sound book and our resources to really hone in on your specific wall assembly and how to build it in order to achieve the exact STC we need. So just keep that in mind as we go through. Wider wall here, but it's not terribly wide, so I wouldn't be too concerned about that. But it is 25 gauge metal, 24 inches on center. Adding another layer of drywall to either side is just minimal difference, maybe 57. Okay, so it's just not going to add a whole lot because it's the same thing. It's not different materials. The damp panel, the SoundBreak XP, is 2 layers of drywall with a viscoelastic polymer in between. The way we manufacture this is we'll manufacture a piece of drywall. Think of a 4 foot or a little bit longer than 4 foot wide paint roller. And we actually have this polymer in this paint roller, and we roll this paint roller, well, actually the board rolls over the roller on the production line and coats it. And then we sandwich the 2 boards together for a total thickness of 5/8. So the total thickness of the board is 5/8. It has tapered edges, as you can see in the picture. It is also a little bit higher density core because it's an abuse-resistant product. So the beauty of the SoundBreak damp panel solution is we can increase your STCs without having to use multiple layers of drywall, which I'm going to show you. And it's abuse resistant, so when we use it in schools or healthcare, where there's a lot of volume of people, airports, wherever we need to use it, it's got abuse resistant qualities to it. And as you can see, the Green Guard Gold logo there, for any of you that do LEED work or any sustainable design type work, that means a lot. You need to have the products that have that symbol. We've got that covered for you. So here we're showing an STC 55. This is a really good wall. So this is a 20 gauge stud, 24 inches on center with 1 layer of SoundBreak XP, the 5/8, okay? It's a 1 hour fire rated wall, and that gives you an STC 55. That will meet the requirements that we need for the 50 or 55. Perfect wall, probably one of the better ones we have. Now, if we have to increase that stud spacing to 16 inches, or should I say shrink it to 16 inches, it's going to take away some STC. And we have testing, we can show you what that is. It will not be 55. So 24 inches makes a huge difference. 20 gauge stud is a good performing, 25 gauge is better. Once you get to 18 gauge or stiffer, it really doesn't matter. It can be 13, 12 gauge, I don't even know there's 13 gauge, but 12 gauge, whatever, 10. Those studs, they're all going to perform the same, and that is poorly, right? So once you're stiffer than 20 gauge, it really doesn't matter. All right, let's keep rolling. Decoupling solution here. 2 options on the left would be a staggered stud. On the option on the right is a better one when it comes to STC, and that's a double stud. And obviously we're separating, it's like building 2 walls. So we're separating the walls. When the sound hits the one side of the wall on the double stud, it's difficult for it to get through. Now I know we have to attach them in some ways, but it's not a whole solid wall attached to another one. Now, moving back left again, kind of jumping on you here, sorry, but moving back left, the staggered studs are good performing, but not as good as double studs because you are sharing a bottom and top plate. So again, it's not totally separating the system. It is a little bit, but not like a double stud wall would. But then the disadvantage of double stud again is floor space. For our when I'm dealing with architects and their clients want every square inch, it's not an option. We have to do other things. So for 24 inch on center steel studs, and we need to get an STC 50, here are your 2 options. We can go with the one on the left with the SoundBreak XP, simple to install, 5/8X on one side, 5/8X SoundBreak on the other. You're going to install SoundBreak the exact same way you do standard drywall, okay? There's no difference in how we do it. In fact, for our UL designs, our fastening pattern is a little bit better than some of the competition. We can do 16 inches on center in certain instances and 12 inches on center in certain instances for the whole board. So there's lots of options out there that you'll see when you dig deep in the assemblies from Gold Bond. But here we go, 24 inches on center, 20 gauge studs, good performing wall 55. Without the soundboard, now we have 20 gauge, 24 inches on center, and we're going to have to add the resilient channel in order to get to the 50. I'm going to hit resilient channel a little bit more when we get to the multifamily section, so I'm going to skip it for now. It does work, it does help. You'll see a lot of sound break assemblies with resilient channel, but there are some concerns with it, but we'll hit that in just a second. 16 inches on center, more apt to what we have to do on a daily basis in order to get our 50. Without the soundboard, we need resilient channel, and we need a little bit, when we use 16 gauge studs, we're going to need to go 6 inches wide. So that width is going to help. We get more insulation in there, helps reduce sound through it, which increases our STC. So again, to the right, thinner wall, that's the big advantage of sound break. We can keep our walls thin and we can get our STCs 50 or above when we need to, even with 16 inches on center studs at 16 gauge. So lots of different options and things out there to be aware of. The book that Chris is going to show you is 120 pages of these things. And we'll actually have links on how you can download all of that. We'll provide all that for you. So let's talk a little bit about wood construction. So I wanted to pick a category with wood, so multifamily. There are some specific challenges when it comes to wood. This slide is probably the most important slide I have for you. Okay, so this slide basically is stating that what the IBC and IRC, International Building, International Residential Codes, allow for is a 5-point drop in the actual field performance of the STC as well as the IIC. The IIC is the impact insulation class. We don't talk a whole lot about that in this presentation, but that is the footfalls, the hardwood floor, click, 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 vibrating right through the floor down to the room below it. Okay, that's what IIC is. So what this means when I talk to architects is when you're designing a wall and you have to have a STC 50 performance, you need to design for an STC 55 because the code knows that when we test it in the lab, the folks putting together that wall are in a lab coat. And when that lab coat, so they're doing it perfect. And there is, I always like to say this, I have never seen a right angle on a job site, right? A perfect right angle. So code allows for this 5-point drop. Sometimes you're going to see some high STC ratings on a wall partition or on a plan. That's why, because they know that it can drop. All right, we have a couple options with multifamily. This is tough because wood doesn't perform all that great. Resilient channels is what we use most often to get our higher STCs. The little diagram there, kind of middle, is a properly installed resilient channel, small flange down, large flange up. Small flange has holes in it, so we can attach that to our stud. Large flange gives us room to hit it with a screw that goes through the drywall into it. We don't want that screw to go all the way through to the stud, though, because we totally defeated the purpose of the resilient channel, right? And then the other thing about the resilient channel, that large flange going up, is proper installation anywhere except the bottom. You'll see in the picture, on that very bottom picture, that resilient channel is upside down. That's okay. We don't expect you all to lay on the floor to install it, but all of the other resilient channels we want up because we're going to caulk underneath this. And as that caulk compresses over time, it'll pull the drywall away from the stud instead of into it. So that's the key. Resilient channels suspend the drywall off of the stud. That's what makes them work. The problem is, and I'm careful here, but the problem is long-term building occupant issues, screwing cabinets in, going antiquing for the weekend, finding this huge ship wheel that I want to bring to the office and hang on the wall. Well, when you do that, you got to get a big anchor, you find a stud, you squeeze it all in, defeats the purpose of the resilient channel. So yes, they perform well, but we have to be concerned about long-term building occupant issues. So we go back, we've already talked about double stud, staggered stud. With insulation, that double stud's probably a 60 STC. And with insulation, that staggered stud there is probably a 58, somewhere in that range. So again, they work. There are options, but when we want to stay real thin, we want to go with the soundboard, the sound break. We've already seen this slide. Don't forget about mass. So a couple layers either way does perform well, but don't forget this is 25 gauge metal, 24 inches on center. So the actual performance, if it was 20 gauge, 16 inches on center, is probably 50, 49, that range, somewhere in there. The stamp panel acts as a resilient channel. Now that we went to the resilient channel, I can mention that. So when we hang or we attach or screw in the sound brake to the stud, what that viscoelastic polymer does is it separates the two boards, right? So as the energy, the vibrational energy hits the one side of the board, that vibration is dissipated by that polymer, and it acts as if it was a resilient channel. That's what makes it work so great. It keeps the wall thin, which is what our clients want, and it performs very well as far as STCs. So again, a great option. 2x4 wood studs, 24 inches on center. This is an STC 50. That is a fantastic wall. Probably one of the best with wood studs. We can meet the 50 requirement with that. And there's no resilient channel. I can't, I'm sorry, folks. I got to do something here. There we go. Okay. So I had a pop up in the way. I had to get rid of it. All righty. So next is STC 50 wood studs, 16 inches on center. So most of our construction is 16 inches on center. In order to get an STC 50 or above, on the left, you got to use a resilient channel, okay? Now, on the right, I'm showing you the same exact wall, except one layer is the sound brake. Now, the sound brake goes up a couple points from a 51 to a 54. That's good. Why is that good? Because the field performance, remember, is allowed to drop 5 points. Our wall on the left will not perform at a 51 its entire existence. It's just not. For our higher end multifamily projects, for those builders that are building high end projects, we need to have that performance because we don't want complaints. Number one complaint, multifamily, is always sound. It's always sound. And it's usually toilet flushing sounds, which is plumbing sounds, or cabinets, kitchen cabinets, opening and closing, just vibrating right through to the next unit. So the sound brake can help reduce a lot of that. Great options there. Here, I'm just showing you mass. Remember, I said mass is good, but it doesn't do us any good with wood studs. They are just so stiff. Our STC with mass here is only a 41. You really need to decouple, and we do that by using the resilient channel. All right, last topic, and I'm going to turn it back over to Chris here in just a second, is education. So the quieter the environment, like I mentioned earlier, the easier it is for kids to learn. I would tell you the quieter environment, the easier it is for us to do our work, right? There's lots of recommendations out there specific to education, and that's why the architects are coming up with some of these STC numbers. LEED version 4, LEED version 5 is under review as we speak. I did a little Google search this morning on LEED version 5, and the numbers are still high. So they're not official, I don't think. I could be wrong. Well, no, it's not official. I know it's not being implemented just yet, but they're to release it officially, I think, soon. And they're requiring some high STC numbers. I saw more 60s on the list. This is just a sampling of some what they recommend. So bottom line here, if you're doing sustainable work and they want certain credits, there's acoustical credits, acoustical performance within certain sections of these systems, and that's why you're seeing higher STCs being specified and being put out on the plans. Room placement for schools is huge. So the ANSI standards are here. These are what they recommend and what the architects are following when they're designing wall partitions in the school itself. So you'll see 50 plus for exterior walls, 60 in between certain rooms like mechanical and classroom, or classroom and cafeteria, you know, those kinds of things. Hopefully we're not putting classrooms right next to cafeterias, but you get the point. There is a method to the madness on why the architects are specifying what they are on specific walls. And again, this is all the ANSI standards here. There's pages and pages of these. I'm not going to bore you with those, but just know that there's a reason why we're looking at specific numbers. Our gypsum board, we've talked about it. Don't forget the sound brake XP is also abuse resistant. Because it's purple, it's also mold resistant. Anything National Gypsum manufacturers, I should say Gold Bond Building Product manufacturers, that's purple is moisture resistant, mold resistant, and in some cases abuse resistant, like our abuse impact boards as well as our sound boards. So we've got the solutions there for you on how to design and put together these walls easily. You know, you're attaching drywall. It's the easiest thing. So let's kind of close things out with some STCs. 45 STC steel stud, 16 inches on center. Here's why we get to these lower requirements of 45. Okay, 20 gauge stud, 16 inches on center, 48 STC there. So we met that 45, no problem. Or we can go to, without the soundboard, we can go to the resilient channel. Don't forget, resilient channels work, but there are some long-term issues with the resilient channels. And they got to be installed right to get the actual performance. Going to 24 inches on center and a higher STC, that's how we get there. We go to a 55, which is a high STC. We can do it with the soundboard, 20 gauge metal, 24 inches on center, easily get to our 55. And to the right there, multiple layers used to get to the 56. So we're using a little bit more thickness, a little bit more labor, right, to do all of that. So thinner wall, less labor on the left versus the right. And then last but not least, our 60. These are the big ones. So this is how we get to a 60. The one on the left is an STC 60, 25 gauge metal, 24 inches on center, and a whole lot of drywall, right? So that's how we get there with that. Otherwise, you have to go to the double studs, or an option is to go to double studs, and there's a lot of space being involved there. Look at the difference between the depths, 6 1/8 versus 10 3/4. Architects are deciding, well, do I want to use the floor space and save a little bit of money, or will I spend just a little bit more money and I get all that floor space, and that's well worth the added cost. So hit you with a lot. I am going to turn it back over to Chris to kind of land the plane.
Scott, as always, great, informative presentation. Well done. Thank you. From a technical support standpoint, we have several options available to you on the screen there on the left. We've got our technical marketing team, our construction design managers. You heard Scott Hughes. He's based out of the Northeast Atlantic. He's also covering the Southeast and Gulf currently. We got Thad Goodman, who's up in the Midwest, and then Amy Wilson's got the Southwest and then also the Western region. Jordy Polk, she's our technical marketing specialist. She's based out of Charlotte here. And then they're all led by our manager of architectural services and sustainability, Miss Amy Hockett. Fantastic, knowledgeable technical marketing team. On the right-hand side, hopefully all are very familiar with the 1-800 National Construction Services Department. Mark Chapman, Jim Farrell, and Sam Halverson. Make sure you have that number plugged in your phone. Three of the very, very best when it comes to knowledge and technical support for any of your construction needs. Just to recap, the SoundBreak XP family of products. Again, we've got 3 of them on display there for you. Our 5/8 and 3/4 inch SoundBreak products, both in Type X, available in Type X and Type C. And then the image there to the far right, that's our SoundBreak XP retrofit. Great product for renovation projects. Scott mentioned it towards the end of his presentation. Purple, moisture, mold, and mildew resistance. When you see purple, think moisture, mold, and mildew resistance. Again, just 3 really great products. One other technical resource we want to just tout is our sound book. This is our acoustical book that houses all of our proprietary sound tests. We have over 300 of those. We've got acoustical terms and concepts in there. Steel stud partitions, wood stud partitions. We've got assemblies in there with for area separation walls. We even have some retrofit assemblies, floor and roof ceiling assemblies, and then ceiling attenuation class assemblies as well. It's just a phenomenal resource. Again, that's all of our proprietary sound tests and assemblies, the sound book. You can download that on nationalgypsum.com. You can also reach out to the 1-800 National Construction Services Department or those construction design managers that we talked about earlier, and we can get you a hard copy of that. Other design and technical resources, we have a design and resource center on nationalgypsum.com. There you'll find fire and sound designs, various technical information, specifications. We've got lead documents and the rest of our product literature and submittals. So plenty of resources for you to go to. And again, If you run into any issues or challenges, reach out to those construction design managers, your local national gypsum field sales representative, or an individual at the 1-800 National Construction Services Department. So with that, that'll wrap up our portion of the presentation. If there's questions, we'll go ahead and field those now.
All right, thank you, Chris and Scott. So first question off here is, since steel studs are better than wood studs and less stiffness is better than for STC, where does that put concrete and CMU walls?
Oh, good question. So concrete and CMU walls are going to perform pretty well. There's a lot, we've got if they're filled with sand, they're going to perform at really high STC walls. So I don't know, Sam, if you want to, we've got a gentleman with us in the room, Sam Halverson, one of our 800 national representatives or guys there. And Sam, I don't know if you want to add anything to that.
Sure. So CME walls are, and concrete walls in general, they are very stiff, but they are so extremely massive that they are pretty good at attenuating sound. Not great. If memory serves, a 8-inch CMU block is going to be about STC 45, and again that can be increased if you fill the cells with sand or perlite's commonly used. That could bump it up a few, but I don't think the 8-inch CMU is going to get above 50 without adding, a gypsum board layer on one or both sides. I don't think. I have to go back and look, but it's going to be generally in the 40s for an 8-inch concrete wall.
Thank you. How do stud spacing and screw spacing affect the performance of your constraint layer damped gypsum board products?
Oh, like that question. That's a new one. So when we do our STC testing, obviously we're going to test on both 16 and 24 inches on center. Screw fastening is not going to affect it dramatically. It's really the studs. I think the biggest I'll give Sam an opportunity, but I think the biggest factor in an STC is really the stud itself. So the softer the stud, the better our STCs, and the fewer studs, the better the STC is going to be. So I don't think that screw fastening is going to affect STCs, at least not a whole lot. And Sam, I'll open it up to you to correct me if I'm wrong.
It does make a difference. You're right. It's not a whole lot. Going from when testing with our Max 12 and Max 16 fastener patterns, you can expect a increase of a couple of points over a typical 1-hour wall that's constructed with fasteners 8 inches at the perimeter and 12 inches in the field. Exactly.
Okay, next.
I should let me just one more thing on that one too. Sam mentioned Max 12, Max 16. Gold Bond Building Products has some great fastening patterns compared to some of our competition on specific fire rated wall assemblies. So take a look, at that. We'll send some links as well for our contractors to make sure you're aware that, there's a lot of walls out there where you can go 12 inches or 16 inches on center for the whole board. You don't have to do the 8 inches. Not every wall. There's specific walls out there, but we'll be sure to send out some info on that.
Great, thank you. Next question. If you were trying to keep or raise STC but couldn't use the 25 gauge or 24 on center requirement due to limiting heights, is it better to increase the gauge or decrease the OC spacing?
Sam, I'm going to let you handle that one.
It's probably a wash. The stud spacing may be a little more effective, but whenever if you can afford the floor space, the best thing to do is, rather than decrease the stud spacing or increasing the gauge, just make the stud deeper. Go from a 3 5 to a 6-inch stud if you can.
There you go. Yeah.
Okay. Scott, for all the solutions that you were showing, what do you see most in the field?
The 20 gauge, 16 inches on center, sound break on one side, 5/8X on the other, with insulation. The 1-hour fire rated wall, the U465 wall. So from a commercial application, you know, I'm pretty much 95% commercial what I do for Gold Bond and National Gypsum. So that is the most popular for getting to your STCs, you know, in that 50 range.
Okay. How do you brace the inside flanges of the staggered steel stud wall? In the image, it looked like there was some sort of bracing strap that kept the studs from rotating. I think that was reference to slide 26.
Yes, I actually looked that up myself. You know, the stud manufacturers will dictate, you know, how to do all of those things. And Sam, I don't know if you want to add anything to that. I just know that that's probably something the stud manufacturer dictates on how to do and what to do. It's
I don't see the slide, but did you say is that the one where you have 3 5/8 studs staggered and a 6-inch track?
yes.
The back leg is fastened to the floor with a small clip angle. They'll just screw the back leg of the stud to the angle and shoot the angle to the floor.
Yeah, the picture actually shows some flange strapping as well. So I looked that up on Clark Dietrich, I think, his website, and it was something that they yeah. I guess.
Well, because the studs are staggered, you're not going to be able to. I'd have to see the picture. I don't think you're going to get the bracing in there because each stud is going to be blocking the bracing. So that's a double row of studs. That's not staggered in a single track.
On the left?
Oh, on the left. That's one way to. I mean, I don't know how. I don't think that's going to take the place of clipping that back leg, but that's a question for Clark Dietrich. I don't know. That's not how we built ours.
Right. Yeah.
Okay. So it's mentioned that the XP products are moisture, mold, and mildew resistant. Can you describe the mildew resistant compared to the mold resistant?
Sure, same thing. We actually use a company called Syngenta. They manufacture a product as an anti-mold inhibitor product. It's called SporeGuard. And we insert the SporeGuard into the pulp of the paper. So the Gold Bond Building Products actually manufactures our own paper for our drywall. So because we do that, we can add the SporeGuard right into the process of manufacturing. So we use it on the front paper, the back paper, and a little bit into the core as well. And it kills mold on contact. Now, that being said, it is FDA approved for human consumption. So it's not going to hurt us as a human being, but it will destroy the mold cells themselves. So mold and mildew resistant, kind of interchangeable. Okay, meaning the same thing.
Is the SoundBreak XP Fire Shield interchangeable for use in the UL systems that include traditional NGC Fire Shield board?
Yes. As a matter of fact, UL does not even recognize the difference in the two products. The core designation for both is FSW.
Can we use Max 12 or Max 16 with SoundBreak XP?
Yes, for 1 hour fire rated UL assemblies on metal studs, yes, you can.
Okay, and
that's 24-inch on center spacing as well.
Last question, what's the difference between an STC rating and IIC rating?
Yeah, I only briefly talked about the IIC. STC, remember, it's airborne sound. Right now, it's me making noise going through a wall. So that's all the STC tells us, is how well that wall partition performs at allowing airborne sound through it. So if I start knocking on my desk here really loud, that's not really STC, that's impact sound. I'm impacting something, right? Footfalls are impacting on the floor itself. So IIC measures how much sound gets through based on that. Think of a hammer tapping on the floor. Boom, 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 boom. And how much of that vibrational energy goes right through our floor assembly with all the building parts to the folks below. So that's what the IIC is. It measures those things. Two totally separate, but both important, obviously, in what we do for a living, measurements. Excuse me.
And last question here, what are the results for STC for 5/8-inch SoundBreak XP or RC?
Excellent question. We test the entire wall partition to come up with the STC rating. So it will depend on a lot of factors: insulation, no insulation. Studs are a big one: size, width, gauge, thickness, spacing. So the sound book is by far your best resource. So you're going to get a link to it. You can download it, and it's going to, again, like Chris said, it's 100 20 pages, 300 actual designs with metal, wood studs, all the different gauges we've talked about, different spacings we've talked about are in that book as well. If you can't find what you're looking for, the last page has got the 800 national phone number, and that goes right into Sam and his counterparts in our construction services department.
Well, thank you, Scott and Chris, for joining us today. Thank you for the informative presentation. That concludes our Q&A session. Thank you, National Gypsum, for sponsoring this webinar. And lastly, thank you to our attendees for joining us. We'll see you next time. Have a good rest of your day.
Thank you. Thanks for having us.
Thank you.